Welcome to this video. We will explore an anomaly detection module to protect the healthcare sector from cyber threats. The second use case of this module is Croydon. Croydon Health Trust is a large organization in the UK. It is based in southwest London and covers the borough of Croydon. Croydon will be involved mainly in the real environment testing and validation processes, including the anomaly detection module by providing labeled CTG data captured from Team 3 devices. The training data include regular and irregular patterns from CTG data collected by Team 3 device. Here is the context of the features. FHR, a regular fetal heart rate typically ranges from 110 to 160 beats per minute, BPM. Tocodynamometry is a measure of uterine contractions. A regular toco reading would be consistent with the normal uterine contractions. MHR, the mother's heart rate. A normal MHR typically ranges from 60 to 100 BPM. Last modified, this column indicates the date and time the action was performed. The main objective is to capture abnormal signals. Anomalies result from abrupt signal changes, like rapid shifts in fetal heart rate. The goal is to detect these irregular patterns, which can manifest as swift signal deviations. Since the Croydon use case involves labeled data and aims to identify abnormal signals, it necessitates multivariate time series classification. The dataset comprises data collected from Team 3 fetal monitoring devices at 10-minute intervals, featuring signals such as 1. Fetal heart rate, 2. Tocodynamometry, and 3. Maternal heart rate. The core aim of multivariate time series classification in this context is to pinpoint anomalies or irregular patterns within these recorded signals. These anomalies can take the form of abrupt signal fluctuations, such as rapid spikes or drops in fetal heart rate. Timely anomaly detection is crucial for ensuring the well-being of both the fetus and the mother during labor and delivery. The algorithm used is LSTM, a recurrent neural network type, excels in handling sequential and time series data by effectively capturing long-range dependencies in sequences. LSTM key characteristics include 1. Memory cells. LSTMs utilize memory cells to capture and retain information over extended durations, enabling them to grasp patterns and relationships occurring at different time intervals. 2. Gates. LSTMs employ gate mechanisms, input, forget, and output gates, that manage information flow, enabling selective memory and forgetting as needed. 3. Vanishing problem. LSTMs are designed to address the vanishing gradient problem in training deep networks, particularly with long sequences. The lifecycle commenced with the acquisition of training data, both normal and abnormal, shared by Team 3 via their device. Next, we conducted thorough data preprocessing to maintain data cleanliness and integrity. A critical step was the resampling process, where we precisely aligned the signal's shape with a 10-minute duration. During training, we introduced a new column called is_anomaly to clearly differentiate patterns and signal shapes. The core of the Croydon use case was the utilization of the long short-term memory algorithm. LSTM, renowned for its proficiency in handling time series data, was entrusted with the task of analysis. Upon successful training, the LSTM model delivered its final predictions for the signals. The outcomes had accuracy rate exceeding 90% and a remarkably low test loss, registering at less than 0.1. In this slide, a screenshot of both normal and abnormal signal shapes was captured and reported to AIR's first layer GUI. Now, we are going to move to the real-time demo that was filmed and presented by the Croydon team.
This video is a demonstration of the use of the AIR module, the anomaly detection functionality within a working system for a medical device. The Team 3 maternal and fetal monitoring system used at Croydon Hospital for monitoring expectant mothers in labor. Dr. Chang is an inexperienced doctor that's just started working on the labor ward at Croydon University Hospital. Dr. Chang logs into the hospital system to start work in labor ward, overseeing the recent admission of a woman in labor. He notes that there's an alert to increased email attacks, so he rings the IT manager to check that the system is working. The IT manager checks the AIR platform and sees that the local and global RAMA scores are normal. and that the Anomaly module is normal, so reassures the doctor that all seems to be well and that he can use the Trust IT system. However, neither IT nor the clinical teams were aware that during the recent service of the Team 3 device, a malcontent engineer had inserted a malware program into the Team 3 operating system. As the Team 3 starts up, it's clear that the signals are very abnormal, suggesting that the baby is in trouble. Dr. Chang, because of his inexperience, is not sure what needs to be done to safeguard the baby. However, the IT manager notes that the Anomaly module has picked up on abnormal signals arising from the Team 3 device, so rings Dr. Chang directly to warn him that the system may be compromised. Dr. Chang therefore uses an alternative Team 3 device to check on the baby's vital signs, and is reassured that the baby is well. He therefore removes the infected Team 3 device in use and continues with alternative monitoring. The labor progresses and the baby is safely delivered. Air today and air for tomorrow. Thank you for your attention.